Hey guys, welcome to question MM409 of the Maths Methods Fortify study guide. So in this question, we've got the customer furniture business is a ruthless industry. Two rival companies work side by side in adjacent factories and are constantly competing for customers. Now the time taken for factory A to produce a piece of custom furniture from the time of ordering to the time of dispatch X hours is given, and this is X, is given by a normally distributed random variable with mean 6 and standard deviation 1.1. So it's normal. Awesome. The time taken for factory B to produce a piece of custom furniture from the time of ordering to the time of dispatch, Y hours, is a random variable modeled by this probability density function here. Now part AI says find the probability that factory A produces a piece of custom furniture in less than 7 hours. Alright, awesome. So this is a 1-mark question, so we don't have to show any working. But the thing to remember, or the thing to recognize, is that because we're dealing with a normal distribution, we've got this normal distribution. Our mean is 6, and our standard deviation is 1.1. So we go 7.2, 8.3, and so on. Now, we're looking for the probability that it produces a piece of custom furniture in less than 7 hours. So what we're really looking for is the probability that X is less than 7. Right, all this area here. So probability that X is less than 7. Now, in order to find this probability, what we do is that we use our normal CDF calculator in our CAS. Now, normal CDF asks you for 4 things: lower, upper, mean, and standard deviation. Now, our lower, we don't actually have a lower because we're looking for everything below 7, which means that our lower is infinity. Our upper, or negative infinity I should say actually, upper is 7, because we're looking for everything less than 7. Mean is 6, and standard deviation is 1.1. Now what this spits out is probability that X is less than 7 equals 0.8183. And that's our first and final answer for part AI. That's our first and final mark as well. And that's it. So let's move on to part AII. Part AII is a little trickier, and it's also a 3-mark question. So this is a nice bulky one. Awesome. Now it says find the probability that factory B produces a piece of custom furniture in less than 7 hours. Alright, awesome. So this one's a bit more in depth. So what we're going to do is whenever we deal with probability density functions, whenever we talk about the probability of something happening within that, what we're actually talking about is the area under the graph, okay? So we're actually looking for all of the area under the graph less than 7, right? So what this kind of looks like, let's just say it kind of looks like, I don't know, something like this. Okay, so we've got two different functions. We've got this function here from 4 to 6, and then this function here from 6 to 238 on 27. Right, so what we're looking for is all the area under 7. So this 7 here. So what we're going to do is break this up into 2. We're going to find the area of this first one from 4 to 6, and then we're going to find the area from this one from 6 till 7. Okay, so what we get is area, which is our probability that X is less than 7. Or sorry, in this case it's actually Y is less than 7, because that's our Y variable. Y is less than 7 is equal to our area, which is our integral from 4 to 6 of our first function, which is y squared over 152 dy, plus the area from 6 to 7 of our second function, which is 9 on 38 dy. This is our first mark. Awesome. So setting all that up is worth a mark. Now what we do is we actually just integrate this as normal. So integration of y squared, we add 1 to the power, so y cubed, and then divide by 3. So what we get is 456. Again, from 4 till 6, plus the integration, 9 on 38 is a constant, so all we do is just add a y on the end. So we get 9y on 38 from 6 to 7. Awesome. Now we can actually sub these values in. So we sub in our 6, then minus our 4. So we get 6 cubed on 456 minus 4 cubed on 456 plus, so it's this bit here, plus 9 outside of 7, so we sub our 7 in, 38, Doesn't matter if this is a y, it's still exactly the same process as if it was an x. Minus 9 outside of 6 on 38. Awesome. That's our second mark. What we get here is then 1 on 3 plus 9 on 38, which simplifies to 65 on 114. That's our third and final mark. So guys, that means that the probability that y is less than 7 equals 65 on 14, and this is the same as the probability that factory B produces a piece of custom furniture in less than 7 hours. Okay, so that's it for part AII, guys. Let's move on to part B. Part B is a 2-mark question and says, what is the average time taken to produce a custom piece of furniture in factory B? Now, B, 2 marks. Awesome. So here we're talking about our average, right? Or our mean. So what our mean is, mean, average, expected value, however you want to say it. So E of y would be our expected value of this, is our average, right? And that's exactly what we're looking for. So the way that we figure that out normally is we do our integral from a to b, so our lower to our upper, of x times f of x dx, right? But this time we've actually got 2 different functions. So some students might get a little bit tripped up by this. I know I did when I was at school. And it can be a bit confusing as to what you do here. But literally all you do is just take this one and plug it into there, and then plus this one and plug it into there, okay? So what I mean by that is we have our formula here, so our lower to our upper, so 4 to 6, so we do our first function first, of y times y squared on 152 dx. You can put these in brackets if you want to, plus the other one. So plus our 6 to 238 on 27 of y times 9 on 38. Okay, so I know this is f and f of x, but if you've got y as your variable, well, that should be dy. If you've got y as your variable, you just sub in y instead. And then that's dy. This is our first mark. And then going through this process gets us our second mark. And we end up finding out that the expected value of y is 6.649 hours. That's our second mark. So guys, that's it for part B. Let's move on to part C. Part C is a 1-mark question. And it's quite straightforward, I guess. There's a little bit of room for interpretation. So what we found out in the previous question, actually, so part C says, generally, which factory should a potential customer go to in order to receive their product in the shortest possible time? So what we found out that if a customer goes to factory B, the average time taken for their piece of furniture to be done is 6.649 hours, right? We found that out in part B. Yeah, part B. What we also know is that with factory A, this is a normal distribution with a mean of 6, which means that the expected time to complete a piece of furniture for factory A is 6 hours, right? So if you're looking at these 2 factories, you're looking at factory B, factory A, who has an average time of 6 hours, and factory B that has an average time of 6.649 hours. It seems logical that you would go to factory A because usually the average is quicker. Okay, so therefore factory A is quicker, and that's our answer. So the customer should go to factory A. And that's our first and only mark for part C. Let's move on to part D. Part D can be a little tricky, especially because we've got these 2 functions. But let's work through it. So part D is a 2-mark question again. And so we've got these 2 functions. I'm just going to redraw them down here. Can we say that? Yep, cool. So we're just going to say something like this. So this straight line here is our 9 on 38, and this is our y squared on 152. Awesome. So part D says find the median of y correct to 4 decimal places. So what the median is the point where we've got half of the data on either side. Okay. So what we want is this value of m, where we've got 0.5 of the data on this side and 0.5 of the data on this side, right? But it's a little tricky because we've got these two functions here. So what we want to do is figure out how much of the area is under our first function, and then we can go from there, all right? And you'll kind of pick up what I'm saying as we go through. I think the easiest way is just to do it. So what we want to do is figure out how much area is under this total function, so that we can tell if our median is going to be under that function or under the other one, okay? So what we're going to do is say that the area equals from 4 to 6 of y squared on 152 dy. And what that gives us is 1 on 3, okay? So because this 1 on 3 is less than 1/2, that means that our median is not going to be in this first function, right? Because there's only a third of the data in here, which means that we have this value of m here, which has half of the data there, a third here, and then whatever's remaining on the left there. So to find out how much, actually, you know what you could do? Actually, no, that would be harder. So if there's a third here and 1/2 here, what has to go here? Well, it's 1 minus 1/3 minus 1/2, right? Which is 1/6, okay? So that means that our area, 1/6, is our area from 6 to m of 9 on 38 dy, right? So we found that the whole thing under here was 1/3. This whole thing is 1/2 because half lies on either side of the median, which means that this must have 1/6 remaining. So 1/6 is our area from 6 to m of 9 on 38. And now we can just evaluate this as normal. Cool. So where we go from here is we can just simply evaluate this. So 1 on 6 is equal to the integral of 9y on 38 6 to m, which means we get 9m on 38 minus 9/6 on 38, which equals 1 on 6. And then we can going to add, okay, so let's just rewrite this. 1 on 6, 9m on 38, take 54 on 38. Now adding 54 on 38 to both sides, we get 181 on 114 equals 9m on 38. So therefore m is equal to 181 on 27, and corrected 4 decimal places, which is what the question asked for, m is equal to 6.7037 hours. That's our second mark. So guys, that's our second and final mark for part D. Let's move on to part EI. Part EI is again a 2-mark question. Oops. And we're going back to our normal distribution of factory A. Okay, so part EI, 2 marks. So it says 70% of the pieces of furniture produced in factory A take longer than t hours. Find the value of t correct to the nearest minute. All right, awesome. So we've got this normal distribution of how long it takes. So we've got this 6 hours in the middle, and a standard deviation of 1.1, 3.8. Awesome. And we're saying that 70% of the pieces of furniture take longer than t hours. Okay, so at 6, at our mean, we have 50% of the furniture taking longer than this. So if we're wanting 70%, it's going to be something like this, right? That's going to be somewhere down here. So this is our t value, right? So 70% takes longer than t. Now, if we know what our area is, as in we know that this is 70% or 0.7, but we don't know our x value or our t value, that's when we use our inverse normal. Okay, so we pull up our inverse normal calculator, and we always use this as soon as we know our probability, as soon as we know the chance of this happening. So we ask for our area, mean, and standard deviation. Now, our area is simply the probability to the left of the point that we're looking for, right? So we know that 70% of the data lies above t, which means that 30% of it lies below it, okay? And we always want to use the area to the left of the point that we're looking for. So this area needs to be our 30%, or 0.3, right? Because we always do it in decimal form. Mean is 6 and standard deviation is 1.1. Now, this means that our t value will spit out as 5.423 hours. But we're not asked for it in this form, we're asked for it correct to the nearest minute. So the way that we do that is we take our decimal off the end, we say 0.423 multiplied by 60, because there's 60 minutes in an hour, and that's equal to 25, which means that t is equal to 5 hours, 25 minutes. And that's our second mark. Excuse me. And that's it. So if you have any questions about that, let me know. That inverse normal is really, really important. So yeah, if you're not too sure about it, just hit me up. But otherwise, let's move on to part EII. Part EII says if a piece of furniture takes less than t hours to produce, the probability that it is a chair is 4 on 5. If it takes longer than t hours to produce, the probability that it is a chair is 1 in 6. A random piece of furniture is chosen. What is the probability that it is not a chair? Right, awesome. So we know that, and recognizing what kind of probability to use here is really important. So as soon as we have something that depends on something else, this is called conditional probability. And what we should do straight away is draw a tree diagram, okay? Because there's multiple pathways that this possibility can take, right? So the time it takes influences whether it's a chair or not, right? So if a chair takes longer than, so a chair can either take less than t hours or more than t hours, okay? So we can say that it's more than t or less than t. There's no other possibility, right? So if it takes more than t, it can either be a chair or not a chair. If it takes less than t, it can either be a chair or not a chair, again, right? So the probability that it takes longer than t is 70%, right? Because the question, part E says 70% of the pieces of furniture produced in factory A take longer than t hours. So this is 70%. But we don't like dealing in percentages here, so I'm going to change this to 7 on 10. Now, if 70% of them take longer than t, that means that 30% of them take less than t. So this is 3 on 10, right? Both of these have to add to 1. Now, the question tells us that if it takes less than t, there's a 4 in 5 chance that it's going to be a chair. So less than t, 4 in 5 chance it's going to be a chair. If it's got this chance to be a chair, that means it's got a 1 in 5 chance to not be a chair, okay? These both have to equal to 1, just like these two do as well. Now, if it takes longer than t, it's got a 1 in 6 chance to be a chair, right? If it takes longer than t, that means it's got a 5 in 6 chance to not be a chair. Awesome. So now we're looking for the probability that it is not a chair, right? So there's two pathways it could have taken there. It could have taken longer than t and then not been a chair, or it could have taken shorter than t and then not been a chair, okay? So we're looking for these two pathways here. And the way that we find those, actually this is your first mark doing this tree diagram. So the way that we do this is by saying we're looking for the probability that it's not a chair, which is the probability that it took longer than t and isn't a chair, and the probability that it took less than t and is not a chair. Awesome. So the way that we do this is now by multiplying all these together. So we get 7 on 10 multiplied by 5 on 6 plus 3 on 10 multiplied by 1 in 5, which is 35 on 60 plus 3 on 50, which equals 193 over 300. This is your second mark. So the probability that it is not a chair is 193 over 300. Guys, that's our final mark for part EII. Let's move on to part EIII. Part EIII is simply a 1 mark question. So we should be able to do it quite quickly. Alrighty, so a random sample of 15 pieces of furniture is chosen. What is the probability that at most 7 of them are chairs? Alright, so we found out in the previous question that the probability that a piece of furniture is not a chair is 193 on 300, okay? But this time we're looking for the probability that at most 7 of them are chairs, right? So the probability that it is a chair is going to be 1 minus the probability that it's not a chair, okay? Which gives us 107 on 300. Now this is the probability that one of them are chairs. Okay, so we haven't dealt with this 15 yet. It's just this is the probability that one of them is a chair. So the thing we have to recognize here is, again, the type of probability that we're using is going to be binomial, okay? Because we've got a certain number of trials that's happening, or a certain number of sample size. We've got a set probability for each trial happening, because for each one of these 15, they all have the same probability to be a chair, okay? And each one does not affect the other. So whether one is a chair doesn't affect whether the next one is a chair, which means we're dealing with binomial. So what we need to do is pull up our Binomial Cdf Calculator in our CAS, menu 55E for me, and it's going to ask us for 4 things: lower, upper, N, and P. Okay, so our lower is going to be, actually, firstly, we're looking for the probability that at most 7 of them are chairs. So that means that we're looking for the probability that x is less than or equal to 7. Okay, so from 0 to 7. So our lower is 0, upper is 7, because it includes 7 in this case. N is 15, and P is 107 on 300, because that's the probability that any given thing is going to be a chair, right? And clicking enter will spit out probability that x is less than or equal to 7 equals 0.8756. Now that's our first and only mark for part E, I. And that actually wraps up MM409, guys. So if you have any questions about any of that, please hit me up in the comments below. But otherwise, thank you for watching, and I'll see you in the next video.